Hello, my name is Nigel Bowden. I'd like to welcome you to episode 18 of the Wi-Fi for Beginners podcast. This is a series of podcasts discussing the fundamentals of wireless LAN networking. In each episode, we'll take a look at a different aspect of Wi-Fi to build your understanding and knowledge of wireless LAN networks. And each episode is accompanied by a set of slides describing the topics covered in the episode. You don't need to review the slides while you're listening to the podcast, but they can be useful to review the material we've been discussing and can provide some visual aids to more fully understand some of the concepts and equipment described. All recordings and supporting material for the podcast can be found at wififorbeginners.com. So that's wififorbeginners.com if you'd like to get along there and check out some of the resources. The podcast itself is divided up into a number of major modules where we look at different wireless LAN topics. We're actually right at the end of module number 5 at the moment. We've been looking at wireless LAN clients for the past few episodes. We started back in episode 13 to look at wireless LAN clients. And in this particular episode, we're going to round that off now and conclude our discussion of wireless LAN clients. If you haven't heard any of the podcasts before, it might be worth you going back to episode 1 to review the episodes right from the start so you can understand the background to the podcast and the various concepts we introduced during the series, which we build on as we move through the various topics. So you might want to go back to episode 1 and start from the beginning, and then all of the things we've covered in this episode will make a lot more sense. Anyway, just before we dive into some new material, I'm just going to take a very quick review of the topics that we covered in episode 17. Just do a very quick review and then we'll be straight into some new material. If you're following along with the slide deck, we actually covered slides number 35 to 44 in the last episode, and we'll just quickly recap those now. So we started off by taking a look at the characteristics and requirements of wireless LAN clients. We mentioned the fact that there are a huge variety of client types with varying capabilities and requirements, which we could be using on our wireless LAN network. And it's really important to understand how they operate when we're designing a network and really understand the way that they behave. And there's a number of key factors that we can have a look at that'll give us a clue as to the sort of characteristics that a client will display. Things like their physical size is going to affect things like the antenna size, number of antennas we can have, and power supply size that we can have for a particular client. We've also got things like the radio components that a client has. Looking at the chipset can give us a good indication of the 802.11 support that it may provide, and we can also look at things like the radio type that it's got, whether we're going to support 2.4 and 5 gigahertz or both. And we can look at the number of antennas it can support, number of streams it can support, things like that. It will give us clues as to the characteristics it will display. And obviously, the 802.11 amendment support that a client can provide is key. This can provide us detail as the types of speed it might support, things like the types of roaming it might support, and whether we've got support for critical features such as QoS, which are vitally important when we're looking at voice and video. We also highlighted the fact that when we're considering the performance of wireless LAN clients, we need to make sure we've got an alignment of feature sets between our wireless LAN clients and our wireless LAN infrastructure. For instance, if we've got a network of 802.11n access points, if we then connect 802.11 AC clients to that network, then they'll obviously never be able to achieve the 802.11 AC speeds which they're capable of. They're restricted by the capabilities of the 802.11n access point. So we need to make sure we have got this alignment between client features and wireless LAN features so that we can reliably predict how our clients are going to behave on the wireless LAN network. We then took a look at how we can determine the capabilities of a wireless LAN client. We went through a process where we can look at a number of sources to understand the capabilities of a client, so we can obviously predict how well it's going to operate on our wireless LAN network. And we looked at a number of sources of information. We initially looked at the manufacturer's documentation, which can be a useful source of information, can be a little bit variable depending on the manufacturer involved. We then went on to look at the Wi-Fi Alliance product finder tool, which is available from the Wi-Fi Alliance website, which is very good for any devices which have been Wi-Fi Alliance certified. Some excellent technical information available from their website. We also mentioned the FCC website, which can be a useful source of technical documentation about wireless LAN clients. We also talked about the fact we can interrogate client data from something like a wireless LAN controller or a wireless LAN management system. And we also talked about using a good old wireless wireless packet analyzer, something like Wireshark, to capture some frames and do some analysis of the individual packets to understand the capabilities. A little bit more involved that, but quite good fun if you've got a little bit of time to kill and want to understand wireless packet analysis. And finally, you can always have a look at Google, but your results and mileage with that will vary. I'd also put together a blog article to cover this process, which is included in the slide deck. We then went on to very quickly look at 4 typical wireless LAN clients and discussed the typical characteristics you will find for each of those device types. I won't go through them now, but we briefly looked at laptops as the sort of original Wi-Fi client in many organizations and looked at its characteristics. We then went on to talk about tablets and talked about some of the constraints that they suffer with battery life and antenna sizes. We then went on to talk about smartphones, which have very similar constraints to tablets. We then looked at a completely different type of wireless LAN client. We looked at a barcode scanner, which you might find in a warehouse or a retail type environment, and talked about its characteristics. We then rounded off the discussion by talking about the fact that whichever client we're going to deploy, we still need to understand the same basic pieces of information. We need to understand the 802.11 amendments that our client will support. We need to understand the radio capabilities of that client, its power capabilities, throughput requirements, its antenna capabilities, and we briefly touched on security standard support, which we'll be looking at in later episodes of the podcast. So we've just got a few more topics to look at as we round off our discussion of wireless LAN clients. We'll be taking a look at wireless NICs, we'll be taking a look at driver and setup utilities, and we'll be finishing off by looking at some of the questions we posed earlier on in this module. We were looking at client behaviours and we posed a series of questions, and hopefully now we've got enough knowledge to answer all of those, and by actually answering those, working through those answers, we'll recap some of the material that we've covered in this particular module. Okay, so we start off by looking at wireless NICs. A NIC is a network interface card. We find on many, particularly mobile devices, they've got onboard wireless chipsets. They're fixed, they're sort of soldered to the main board of the device itself. So they're not really classed as NICs as such. They're not removable network interface cards, but we have got a large number of devices which have got what I would classify as a wireless network interface card. It's a removable card that you can swap out or add to a device. They can be actually plugged into the main motherboard of the device, or you can plug them into maybe a USB socket. And we're typically talking about devices such as laptops. It could be a Windows laptop, or maybe an Apple Mac or a Linux laptop. Different types of flavors of laptops, but they all support very similar types of hardware. The capabilities we're going to get out of a wireless NIC is going to vary depending on its form factor and the power available to it, and also the NICs may have an integrated antenna assembly, or it may well be that you actually have to plug in or supply an external antenna to work with it. So we're just going to take a look at a few typical wireless LAN NICs that you may come across. The first one we've already touched on is an onboard NIC that we find on the motherboard of a laptop. And it's generally either plugged into something like a PCI slot, or it can actually be plugged into some other connector which plugs into the main motherboard itself. And quite often these have separate antennas which are actually housed in the screen of the laptop. If you've ever taken a laptop screen apart, you'll see some wires maybe either side of the screen, and these are actually the antennas that accompany the onboard wireless NIC. We can also have a PCI bus NIC. Generally use this on a desktop machine more than laptops, and it's a wireless NIC card which plugs into the PCI bus of your desktop machine, and very often has external antennas which you can see protruding from the NIC card itself. If you have a look around the back of a desktop machine that's got a wireless card, you'll often see a black rubber duck type dipole antenna sticking out of the back there, and that's what this is. And if you have a look on slide number 46 of the slide deck, I've actually provided a picture there so you can see the sort of thing we're talking about, of both a PCI based card, and also we've got a NIC card which plugs into the motherboard of a laptop. The picture of the NIC card that plugs into the laptop is just the actual NIC assembly itself. It doesn't include the antennas. And if you look very closely, you can see there's a couple of connectors where you plug in the antennas, which generally reside in the screen housing of the laptop itself. One of the most common form factors you're likely to come across is a USB NIC. It just plugs straight into the USB slot of a laptop, and it's a very low cost way of extending the support of your laptop. If you've got a lower cost type machine, you may well not have 5 gigahertz support, for instance, or maybe you haven't got 802.11ac support, and if you want to add this to your laptop, you can simply buy yourself a USB NIC, plug it in, and away you go. The only caveat with USB NICs is that you have to be a little bit careful. They can protrude quite a long way sometimes out of a USB slot. If you're moving around, it's quite easy to snap those off, which is obviously not a good thing. And they generally have an internal antenna as part of the USB NIC assembly. They've got a little onboard antenna. You don't have to worry about providing external antennas with most models that I've seen anyway. Slightly different form factor that we've got as well is an SD NIC, that's secure digital. If ever you've seen the SD cards that you put into your digital camera, it's the same form factor as that, and it's generally got a very small antenna which protrudes very slightly outside of the SD slot, and these can provide wireless LAN connectivity in the same way that USB NICs can. In addition to this, there's obviously a variety of other NICs that I haven't had a chance to cover. There's quite a few PCI varieties out there and some compact flash, but these are certainly some of the most common form factors that you'll see. And if you have a look on the slides, slides 46 and 47, you can have a look at some examples there. I've provided a few pictures. So I just want to take a little bit of a look at drivers and setup utilities for these wireless NIC cards. Like any other piece of hardware that you add to a laptop or a desktop, a wireless NIC needs some sort of driver software. This allows the operating system of the desktop or laptop to talk to the hardware, and if we don't actually install the driver software, then we certainly don't get anything out of our wireless NIC card. We talked earlier about devices such as tablets and other mobile devices that have got onboard chipsets, and they certainly don't need any sort of client driver installing. They generally are supplied as part of the operating system of the device. But when we're talking about a wireless network interface card that we can add to a device or an onboard wireless LAN NIC, then we certainly need to have some sort of driver software added. And when we're thinking about things like our laptops, desktops, and we're maybe running Windows, Mac or Linux operating systems on there, we need to obviously load some software drivers for our NIC to talk to the operating system. And the drivers which are required may actually be part of the operating system itself, especially things like Windows has got many drivers already embedded as part of the operating system, or it may well be that you have to obtain them from the manufacturer and install them to make them work with your particular operating system. One thing to note here though is that you really need to make sure you've got the latest version of driver. This is one thing that's often overlooked. It may well be that the driver software is updated periodically by the manufacturer, and this may well fix issues that you've been experiencing with your wireless LAN clients that are often attributed to the wireless LAN infrastructure itself. I've seen many instances where organisations have brand new laptops which they've received from the manufacturer. They deploy them onto their wireless LAN network, and they may have ongoing problems which they never quite get to the bottom of. But one thing they've never actually done is taken the time to have a look at the drivers which are installed with their wireless LAN NICs to see if there's actually a more up-to-date version of that particular driver. And very often just a simple update to the latest and greatest driver can make a huge difference to the performance of those devices on a wireless LAN network. And especially if you're upgrading a wireless LAN network, it can well be that a change to 802.11 amendment support can have an impact on older drivers. It may well be that in the newer access points which support later amendments, there are one or two information elements within the frames which those particular drivers don't like, and by simply upgrading to the latest and greatest firmware, it can get rid of some of those problems and make things run a lot more smoothly. So that's something that's really generally overlooked by a lot of organisations, taking the time to investigate whether or not they're actually running the latest drivers for the wireless NICs in their laptops. So in summary, we need to be aware of wireless NIC drivers, because without them, our hardware simply won't work. If we add new hardware to our devices, we need to make sure we add the correct drivers for them to operate as we expect. And also, we need to bear in mind that the performance of wireless LAN clients can be significantly improved by performing regular driver updates to make sure we're using the latest and greatest drivers. And this will often clear up quite a few problems on wireless LANs that we're experiencing with our wireless clients. In terms of installing drivers for our wireless NIC cards, it's a pretty straightforward process. Many operating systems work with a plug-and-play system. You simply plug them in, and the operating system may already have the drivers bundled into them, or they may simply update the drivers from an operating system update site. We can also download the drivers from the support page of the wireless NIC manufacturer. Download the driver onto our local drive, and then we can get the operating system to search for the drivers. Perhaps when we plug the new wireless NIC in, it'll automatically search for them. Or we may download the manufacturer's NIC utility software, which can either download from the software. It could be bundled on a CD or DVD, which comes with the wireless NIC itself. And this is generally a bundle which includes the NIC drivers, which we need as well, but it also has some very useful supporting software utilities which can be used to configure the wireless NIC itself. So once we've got our wireless NIC installed and operational, because we've installed the correct drivers, we need some sort of setup utility to allow us to configure it to work with our wireless LAN infrastructure. When we plug a card in and get it going, it doesn't just automatically connect to our wireless LAN. We need to actually give it some configuration parameters, and there are a number of different setup utilities that we can use, which can be manufacturer specific or even operating system specific. And things we'll set up will be things like the SSID that we want the wireless NIC to connect to, the type of security that we're going to use to connect to that network. We can actually use it to perhaps connect to a preferred band. We might want to prefer to use the 5 gigahertz band, and also the level of 802.11 amendment support that we want it to use. We may not want it to use 802.11b speeds, for instance, or maybe 802.11g, so we could configure it to only support 802.11n and maybe AC. It will vary from device to device, but we do have some control over that. In the Windows world, we've got a native configuration utility which allows us to configure wireless network interface cards. You may have seen this if you're familiar with Windows, and we use the same configuration utility to configure most manufacturers' wireless NIC cards. But you can actually download a vendor-specific configuration utility. You don't have to use the built-in Windows utility, and the vendor utility may have some additional features which you don't have with the built-in Windows configuration tool. Many organizations tend to prefer the built-in Windows native configuration utility because it is very easy to configure, especially in an environment where you want to apply a Windows AD policy across large numbers of devices. It's a very straightforward process to apply from Windows AD itself, rather than having to go around configuring individual wireless NIC cards. But it is definitely worth taking the time to correctly set up a wireless NIC card using some sort of setup utility, and find it can actually improve the performance of the client and of course the whole of the wireless LAN if you've got all of your wireless clients configured in an optimum way. This is one aspect that many organisations fail to actually take the time to undertake, and they may go with default settings for their wireless clients, and certainly don't ever realise the potential throughput and features which they could actually enjoy if they just took a little bit of time to correctly configure the wireless NICs of their devices. Okay, and finally, we're just going to revisit some of the earlier client-related questions which we posed when we were taking a look at client behaviour and trying to understand it in a little bit more detail. The first question we actually posed was, which band will a client use? If we've got a wireless LAN client in front of us, how do we know which band it's actually likely to use? Well, there's a number of factors that we've got to consider, and hopefully you will have picked up on most of these during our discussions. One thing which will be a factor will be the SSID that it's configured to use. Is the SSID that it's configured to use on the 2.4 gigahertz or the 5 gigahertz band? They don't necessarily have to be on both. So which SSID we choose can be one of the factors which decides whether or not our client is going to connect to 2.4 or 5 gigahertz. How is the client itself actually configured? We just talked about client setup utilities. How is the client configured? Is it configured to support both 2.4 and 5 gigahertz? That's assuming it actually has the physical capability within its radios to support either of the bands. And the actual native behaviour of the client itself as well is a large factor. For instance, until recently, many devices preferred to connect to the 2.4 gigahertz band. And when they were fired up, if they had an SSID which is available on both the 2.4 and 5 gigahertz band, they would naturally tend to use 2.4 gigahertz band. It was configured into their connection algorithm. But as clients have evolved, more and more clients are now tending to prefer 5 gigahertz as manufacturers have come to understand the benefits of using 5 gigahertz over 2.4 gigahertz. But as I say, it is a function of the behavior of the client itself. So we need to understand that when we're trying to understand which band a client's going to use. And of course, which 802.11 amendments a client supports are a large factor. For instance, if we have a client which only supports 802.11g, it will obviously only ever work on the 2.4 gigahertz band. Many modern devices will support multiple 802.11 amendments for backwards compatibility, but we do need to understand which ones they support to understand which band they have the options of using. The next question we posed was, which channel will a client use? If we have a wireless LAN client which is about to connect to a wireless LAN network, which channel will it actually use? Obviously, just looking back at the previous question, the channels available will depend upon the band which is chosen. So in 2.4 gigahertz, we probably only have channels 1 through to 11 or 13. And if we've got the option of using the 5 gigahertz band, we've got channels 36 up to around about 140, depending on which part of the world you're in. But obviously, the channel that's used will be related to the band which is chosen. But when considering which specific channel will be chosen, once we've actually made the band choice, we need to think back to the way that a wireless LAN client works. If we think back to our discussion of client scanning, when a client needs to find a wireless access point, we have two types of scanning it can perform. We have passive scanning, where a wireless client is actually listening for beacons which are being broadcast by wireless access points, or it can do active scanning, where it sends probe frames out to actively find wireless access points. And in many environments, a client will find a number of suitable wireless access points. Generally, a wireless LAN client will hopefully find a number of access points through these probing mechanisms, and it will generally select the one which has got the highest signal level, which is hopefully going to represent the best choice for it to associate with and connect to the wireless LAN network. So in terms of the actual channel which would be used by the client, as it's associating with a specific AP which is chosen, it will operate on the same channel as the AP that it's associated to. We also asked the question, which AP will a client use? And this is particularly pertinent when we're thinking about things like roaming and moving between access points within a building. And as we've talked about in our previous discussions, the actual AP that a client will use is very much dependent on the AP signal strength. As a client moves through a facility, it will hopefully roam from AP to AP, and as it detects the signal level of its currently connected AP dropping off as it moves away from an AP, hopefully it'll make a roaming decision and it'll move to a new access point which hopefully got a slightly better signal and is going to give it a better quality connection. There's also some other decision points in there as well we need to consider. The client also needs to decide whether or not the AP supports the same 802.11 amendments as the client to see whether or not it's actually viable for it to roam to that particular AP. And so during the frame exchange with the new AP, we'll actually determine capabilities and decide whether or not it can actually roam to the new AP. So just to summarise the answer to the question, the AP that a client's going to use is going to depend on the signal strength of that particular AP and also the capabilities of the AP, whether they actually align with the capabilities of the wireless client itself. And of course, the AP must support the SSID that our client needs to use. And finally, we asked, when and how will a client roam to a new access point? This very much depends on the RF design of our wireless LAN network. Hopefully, we've spaced our APs so that they're nice and evenly distributed through a facility from an RF perspective, which gives our clients the opportunity to roam from cell to cell as they actually move through a facility. The actual client itself will detect that the signal of the access point that it's associated to is falling off as it moves away from an access point and is moving into another cell area. It'll detect that there's a degradation in the signal quality that it's achieving with that access point, and it'll then decide to make a roaming decision. At that point, it'll start to probe for other access points which are using the same SSID. It can use active or passive scanning to achieve this, and when it finds a suitable access point, it will then be able to reassociate to the new access point and continue its wireless LAN connectivity. But this is also influenced to a degree by the native behaviour of the wireless LAN client itself. Many clients do display what we call a sticky behaviour, which we've talked about in some detail in this module, whereby they will actually associate with an initial wireless access point, and despite the fact they're moving away from the access point and the signal's actually dropping off, they will stay stuck to that particular access point until they've reached a very poor signal quality and have no option but to roam. And we talked about the fact that this sticky behaviour was associated with devices which are consumer grade devices which were originally designed to be used in the home, where the assumption was there would be a single access point somewhere in the home and the device would need to cling on to that single access point for as long as possible, as there were no other options which it would expect to have available to it. So that brings us to the end of this module on wireless LAN clients. Hopefully by running through those few questions, it's jogged your memory on some of the topics that we've covered. We've certainly covered a lot of ground in this particular module, but it's a very important topic which I think we needed to explore in quite a bit of depth. Just in summary, the areas that we've actually looked at in this module, we've looked at what is a wireless LAN client. We've looked at a review of 802.11 amendments. We've looked at the evolution of clients over time, how we've actually arrived at where we are with today's wireless LAN clients. We've looked at client behavior, 802.11 frame types. We've looked at client speeds, characteristics and requirements of clients. We've looked at wireless NICs, and we've finished off by looking at drivers and utilities for wireless NICs. In the next module, we'll be moving on to a completely new topic. We'll be looking at wireless control and management. And in this particular module, we'll be looking at things like wireless LAN controllers, the control plane, the management plane, and the data plane of our wireless LAN network. We'll be looking at the need for centralized management for coordinated control, looking at the functions of a wireless LAN controller, a little bit about the history of wireless LAN controllers, and alternatives to wireless LAN controllers. So some pretty interesting stuff ahead, and we'll be starting that in the next episode, which will be episode number 19. So just want to remind you to get along to my website to find all of the resources associated with the podcast. Go to wififorbeginners.com. I'd also like to strongly encourage you to sign up for my monthly newsletter that accompanies the podcast. It gives you access to a lot of additional resources to complement the podcast and to give you access to additional resources to help you with your wireless LAN studies. So thanks very much for joining me. I look forward to joining you again soon on the next edition of the Wi-Fi for Beginners podcast.